first is driven steel tube piling. Driven steel tube piling are large hollow tubes which are driven or vibrated into the ground with the use of a Movax vibro hammer, or other efficient modern accelerated hammers. Steel tube piling vary in diameter, with up to 4.2 meters diameter piles installed in Australia. Piles are generally delivered in longest lengths permitted on the road and then spliced on site where required. Driven steel tube piling is a cost-effective technique in suitable ground conditions. They are driven to a predetermined level and checked for capacity, following which they are partially excavated over the upper 12 to 18 meters section of the pile, where a reinforced concrete pile shaft is then cast to allow load transfer between the steel tube and the reinforced concrete shaft is via adhesion and shear connection between the concrete and steel, and between the steel tube and the soil by friction. Piles are driven using hydraulic impact hammers either mounted on a leader rig or rope suspended from a crane. This is basement excavator, bored pile. Bored pile foundation or drilled shaft foundation is a commonly used foundation for supporting heavy vertical loads. It transfers the load to the soil below or rock strata with sufficient bearing capacity and reduces the settlement of the structure. The construction of the bored pile is divided into two phases, the drilling phase and the construction phase. In the drilling phase, the spoil is removed to form a hole of the required diameter and depth, while during the construction phase, the reinforced concrete is poured in situ. Therefore, bored piles are also called replacement piles. Bored piles are popular in urban areas where minimal vibration is a prerequisite during construction. Moreover, it is employed where the headroom is limited, the depth of the piles remains the same, and there is no risk of heaving. Bored piling process. Installing a bored pile starts with drilling a vertical hole into the soil, using a bored piling machine. The machine can be outfitted with specially designed drilling tools, buckets, and grabs to remove the soil and rock. Piles can be drilled to a depth of up to 60 meters and a diameter of up to 2.4 meters. The drilling process may include driving a temporary steel cylinder or sleeve into the soil. This remains in place in the upper portion of the hole until the pile is poured. Once the hole is drilled, a structure of reinforcing steel rebar is built and lowered into the hole. Then the hole is filled with concrete. The top of the pile may be capped with a footing or be near ground level to support the structure above. Bored piling work must be done by bored piling contractor. It is a highly specialized operation requiring extensive knowledge and experience of bored pile construction and engineering as well as soil and site conditions. Bored pile applications. When used for foundations, bored piles are specified for buildings and other structures that impose loads in the thousands of tons. They are also particularly well suited to unstable or difficult soil conditions. In addition to foundation systems, bored piles are used to create structural underground walls for earth retention. Piles can be placed close together, with 75 to 150 millimeters between piles called a contiguous pile wall. Or they can be placed so they overlap, to create a secant pile wall, which is often used to control migration of groundwater. Challenges to bored pile construction. Like any other deep foundation system, bored piles present challenges for the contractor. Because the drilling method used depends on the soil type, the contractor must complete a thorough soil investigation and report. The piling contractor relies on the soil report and past experience to choose the best drilling method that will minimize the disturbance of the surrounding soil. Advantages of bored pile construction. Bored piles facilitate easy movement of the piles to variable depths irrespective of the soil type. It extends the pile till the bearing strata is approached. Bored pile works best in soft, compressible, and swelling soils. Bored pile foundation can be extended to depths below seasonal moisture variation or frost penetration. Bored pile foundation prevents the need for large excavation and subsequent backfilling. Bored pile foundation does not disrupt the adjacent soil drastically. Vibration and related disturbances due to bored pile foundation construction are relatively low compared to conventional foundation methods. Bored pile foundation offers higher bearing capacities compared to other driven piles. Next is large diameter shaft drilling. When a project presents heavy loads and is large enough to justify mobilizing the equipment, the most suitable type of piling is currently the large diameter drilled shaft cast in situ. This kind of pile has become ever more popular due to the practicality and speed of installation and its adaptability in different soils, as well as giving the advantage of being able to immediately visualize and recognize the material being excavated into. Piling Contractors has a range of dedicated crane-mounted rotary drill rigs designed and manufactured in Australia specifically for shaft drilling. With torque capacities up to 50 tons and capable of drilling 7.5 meters diameter shafts to depths of 100 meters. This equipment is suitable for drilling the clays, shales and weaker rocks that historically have proven unsuitable for raise bore equipment and other hard rock drilling systems. The drill system of the augers and buckets comprises ground engaging tools equipped with teeth for cutting the formation by drag action. The auger drill bit, although many times larger, is similar to that of a carpenter's wood auger. As the formation is cut, the cuttings accumulate on the auger flights, and they are removed from the hole by withdrawing the auger to the surface and spinning it to dislodge the cuttings. Continue to be dam-cut-off wall, seepage barrier construction, plastic diaphragm wall. Diaphragm and cut-off walls are specialist foundation engineering methods with many advantages for dam sealing, securing of deep excavation, and the retaining of medium and large excavation pits of great depths. They can serve as a temporary or permanent part of the structural design and take on a ceiling and or load-bearing function. Diaphragm wall is a reinforced concrete structure constructed in situ panel by panel. The wall is usually designed to reach very great depth, sometimes up to 50 meters. The primary advantage of a diaphragm wall over a secant wall is the reduced number of joints in the wall, which ultimately improves the wall's water tightness. Diaphragm walls tend to be used for retaining very deep excavations, as they can be designed to take very high structural loads. Construction sequence. Guide wall is two parallel concrete beams constructed along the side of the wall as a guide to the clamshell, which is used for the excavation of the diaphragm wall trenches. Trench excavation, in normal soil condition excavation, is done using a clamshell or grab suspended by cables to a crane. The grab can easily cut through soft ground. In case of encountering boulders, a gravity hammer chisel will be used to break the rock and then take the spoil out using the grab. Reinforcement is inserted in the form of a steel cage, but may be required to lap a few sections in order to reach the required length. Concreting, placing of concrete, is done using tremie pipes to avoid the segregation of concrete. As concrete being poured down, bentonite will be displaced due to its lower density than concrete. Bentonite is then collected and reused. Finally, construction of the Ahrensfeld-Wittefeld wind farm in Bramsk. In everyday life, you've probably come across those colossal white windmills, their blades turning slowing in the breeze. These wind turbines harness the kinetic energy of the wind and turn it into valuable electricity. Germany is an ideal place for such a renewable energy source and currently has 1,169 wind turbines with an installed capacity of 5,387 MW connected to the grid. Wind turbines have had their critics over the last few years, notably because of their impact on the aesthetics of the environment, but that hasn't stopped the development of new fields to help meet renewable targets for the next decade. How is a wind turbine installed? The length and complexity of the installation process depends upon the size and type of wind turbine. Prior to any installation, it is necessary to commission a technical survey of your site and monitor local wind speeds over a period of time at least 3 months. Step 1. Foundation preparation and installation. Depending on the size and type of turbine system, this may require heavy machinery such as an excavator and crane. It is usually necessary to wait for a period of at least 2 weeks after the laying of foundations in order to allow the concrete base to cure. If a building-mounted system is being installed, it may be necessary to have your property's roof strengthened so that it can bear the weight of the turbine. Step 2. Digging of trenches. Trenches need to be dug for the electrical cables which run from the turbine to the control unit and inverter. Step 3. Erection of tower and turbine. Depending on the turbine size, this may require use of a crane. Step 4. Electrical wiring. An electrical engineer or electrician will connect the wind turbine's DC output to the control box and then the inverter. The AC output from the inverter will be connected to your property's electricity supply and the electricity grid. Other electrical components such as isolators are installed for safety. And an Ofgem-approved generation meter will be placed after the inverter. Step 5. Connection to electricity grid. In order to connect the wind turbine system to the grid, your installer will liaise with your local district network operator DNO. Last step, final checks. Your installer should perform final electrical safety and performance checks before commissioning the system, and provide you with the necessary documentation manuals. Warranties, maintenance information. The installer should also register your turbine system with the Microgeneration Certification Scheme, which will provide you with the certificate needed to apply for feed-in tariff generation and export payments. How does a wind turbine work? Wind turbines work on a very simple principle. The wind turns the blades, which causes the axis to rotate, which is attached to a generator, which produces DC electricity, which is then converted to AC via an inverter that can then be passed on to power your home. The stronger the wind, the more electricity is generated from the motion. That's why we tend to see industrial-scale wind farms with high towers and large blades located in the breeziest parts of the countryside, including offshore. A turbine's efficiency comes from how well it captures the power of the wind and turns it into a rotational torque that can then push electrons out from the generator and into the grid. The towers are normally made of steel, but the blades can be manufactured from glass fiber or reinforced polyester that need to be strong yet light enough to turn in the wind. A single 1.8 MW wind turbine running at normal capacity will produce enough electricity in a year to feed 1,000 average homes. The Whiteley Wind Farm in Scotland has 140 turbines that provide electricity for around 180,000 homes. How a wind turbine creates electricity. The core component of a wind turbine is the generator, which converts mechanical energy into electricity. We've known since the early 19th century that if you turn a conductor in a magnetic field, then it creates electricity, according to Faraday's law. So the wind provides the movement and torque, and the generator does the rest.